everyone, welcome back to my channel. My name is Saffron and I bring you science, books and all sorts of random stuff. Now I've got a lot of requests on doing a video on how to calculate molarity. So that's what we're going to be talking about today, and I'm going to break this down into really simple steps. So if you're already a little bit familiar, feel free to jump ahead in the video. So firstly, molarity. The units for molarity are moles per litre. Now you'll probably notice that in a lot of my videos I harp on about units, and that's because they really give us a hint to what we're talking about. So firstly, to calculate molarity, you need to know two things. You need to know the number of moles and you need to know the volume in litres. So what does this even mean? How do we find out this number of moles? That's what we'll be talking about first. And I think a lot of people get scared by this term mole because what does it even mean? You know, you start bringing in Avogadro's numbers and people get confused. So we're going to talk about it really simply in today's video. So for the moment, let's get rid of moles. Let's forget moles. Let's instead talk about jelly beans, right? Let's say one jelly bean weighs 10 grams, okay? So you could say the jelly bean weight is 10 grams per jelly bean. All right, that's pretty straightforward, right? And then let's say we have a pile of jelly beans, all right, like this. And let's say that our pile of jelly beans weighs, let's call it 100 grams, okay? So how do we find out our number of jelly beans in this pile? Well, hopefully you can see that number of jelly beans is equal to the total weight of jelly beans, so that's our pile there, divided by the weight per jelly bean, or our jelly bean weight, all right? Jelly bean weight. Now, we know that our total weight is 100 grams, just there. We got our jelly bean weight here, which was 10 grams per jelly bean. So, if we extend that out, we get 100 grams, that's our total weight, divided by our jelly bean weight, which was 10 grams per jelly bean. Now note that I'm keeping the units there. This is important. All right, so if we solve this equation, obviously we can get that right there. 10 divided by 1 is, of course, 10. Our gram units cancel out, and we're left with a divide jelly bean, which hopefully you know brings the jelly bean up to the top, so we're left with 10 jelly bean. All right, so in our pile, we can say that our number of jelly beans is 10, or we have 10 jelly beans. Now, the exact same equations can be used to talk about moles, all right? So let's just say that we have a substance X, all right? And its molecular weight is 10 grams per mole, right? Now, hopefully you're seeing similarities to our jelly bean example. So each unit of X equals 10 grams, all right? Now, let's say we have a pile of chemical X, all right? And there are 100 grams in our pile. So to get the number of moles of X, okay, moles of X, we need the total weight of X, which we got here, divided by the weight per X, or our molecular weight, all right? So molecular weight is often shortened to MW of X, all right? So our subscript tells us what it is there. And we got this here. We know that it's 10 grams per mole, all right? So if we solve that out, our total weight was 100 grams. Our molecular weight is 10 grams per mole, which gives us 10 grams, cancel each other out, right? Per mole, which gives us 10 moles, right? So we can say that in our pile, we have 10 moles of X. Now let's look at that for a real chemical example, all right? Now remember, for the moment, for our molarity equation, we're just looking at the first component here, calculating our number of moles, all right? We'll get to the volume in a second. So let's consider a real chemical example, right? Sodium chloride. Now, the molecular weight of sodium is equal to 23 grams per mole. The molecular weight of chloride is equal to 35 grams per mole. All right, so that means that our molecular weight of sodium chloride, all right, so the two together, is equal to the molecular weight of sodium plus the molecular weight of chloride, which is just 23 plus 35, which is 58 grams per mole. All right, so each mole of sodium chloride weighs 58 grams. Now, let's say we have a pile of sodium chloride, so just like our jelly beans, just like our substance X, all right, we have a whole pile of sodium chloride, or a whole pile of salt, and we know that our pile weighs 100 grams. Now we need to know how many moles of sodium chloride are in that pile. All right, so hopefully you know the equation you have to use. I'll give you a couple of seconds. Okay, so it's exactly the same equation we've been using. So our number of moles of sodium chloride is equal to our total weight divided by the molecular weight of sodium chloride. All right, now our total weight is over here, it's our 100 grams, and our molecular weight we calculated here to be 58 grams per mole. All right, so I'll let you do that equation. How many moles of sodium chloride do you think we have? All right, pause the video if you need to. Hopefully you can see that we need to divide 100, that's grams, that's our total weight, by 58 grams per mole, which is our molecular weight. Now, if you do that equation, it comes out at about 1.72. Remember, our gram units cancel out, and we're left with moles. Okay, so 100 grams of sodium chloride is 1.72 moles, which is good. So if we go back to our molarity equation here, molarity equals number of moles per liter. All right, so we've got the first part of this equation here. It's our moles, so we've 1.72. But how do we know the actual concentration? How do we get molarity? Well, for this, we need to know this second term, the volume. So let's pretend that we have a beaker of water here, okay? And we know that it's 1 liter, all right? Let's say it's a 1 liter. And we also know that we put 100 grams of sodium chloride in there. Okay, so we took our pile of sodium chloride here and we put it into 1 liter of water. All right, well now we've already calculated the number of moles that are in 100 grams of sodium chloride. We calculated that to be 1.72 moles. And we know our volume here, which is 1 liter. So if we put that into our molarity equation, we've got 1.72 moles divided by 1 liter. Now, of course, 1.72 divided by 1 is just 1.72, and we ended up with moles per liter. So there's our molarity. Okay, so the molarity of sodium chloride. Now, quite often, instead of writing moles per liter, the units will just be m, all right? So 1.72 m, that's our molarity. But what if we look at a more complicated situation? So let's say we have a beaker, again, and we've got our 100 grams of sodium chloride sitting in there. But what if there's only 500 mils, or 0.5 liters of water? We do exactly the same thing, so we just plug those values into our equation. Okay, so our molarity equals our number of moles, and that hasn't changed. We still have 100 grams of sodium chloride, so we still have 1.72 moles. But now our volume component here is only 0.5. So we divide by 0.5 liters, all right? Now, if you do 1.72 divided by 0.5, you get 3.44. And then our units, moles per liter, or you can simplify that down to 3.44 m, which means exactly the same thing. So our molarity in the second case here is 3.44 mole. Now just think about this logically. It makes sense, right? We're talking about the concentration of sodium chloride. Now in the first case, you've got 100 grams of sodium chloride in all this water. But in the second case, you've got the same amount of sodium chloride, but in much less water. So of course, the sodium chloride is going to be more concentrated in the second case. Now I'm going to go through one more example with you, and I really encourage you to pause the video and have a go at calculating it yourself before you watch me walk through it. Okay? So in our final example, we have our beaker, all right? We have our pile of 100 grams of sodium chloride. But this time, we've got 2 liters of water, all right? So what is our molarity of sodium chloride in that case? All right, so remember, molarity is the number of moles per liter. All right, pause the video now and have a go at calculating this. All right, hopefully that went well. So let's write it out here. Our moles is the same as what we've been using, all right? We've still got 100 grams of sodium chloride. So we still have 1.72 moles of sodium chloride. And then our second term, the liter term, we've got over here is 2 liters. So we divide by 2 liters. Now, if we solve that out, it comes out to 0.86 moles per liter, or 0.86 m molarity, all right? Now, just like in our other examples, here we have the same amount of sodium chloride, but now it's in even more water, all right? We've got extra water there. So, of course, the concentration of sodium chloride is going to be less than in our other examples. It's more dilute. Hopefully that makes sense. Please let me know if you have any questions in the comments section, and also let me know if there's anything else you'd like to see a video on. I hope you have a great day.